So last time we were here, we create a point matrix, right? And then we use these three attractor points to move it up or down, right? So here we use the distance, and we map this distance into the parameters and to control the moving, right? So like moving up or down. Of course, you can make it use this distance and map it to another parameters and to do other transformation like a rotation, like a scaling, everything. So for example, you can do very simple thing that if we want to make the sphere here, we can do that. We can make a sphere here, and we can also control the scale with this distance, right? So if we do this thing, but I'm not going to do the sphere, I'm going to do the cube. So just follow me. Let's do a cube here. So go to Rhino. Let's make a cube. So use box. I'm going to make one unit cube. So I just click anywhere on the canvas, just type 1 and 1 and 1. So that will be a cube. Okay. So I'm going to map this geometry, this cube, to all the points here. So remember the sample we did here. This is the first one. Here I want to share this one. This one, right? Let me use another file. Right? What I'm looking at is this one. I want to finish this one. So I want to map these cubes to all the points. So it's straightforward. As long as we can find the center of this cube and we just move it, right? So here, let's use the geometry. Just double click in your grasshopper. Once you've done this cube, let's double click on the grasshopper and let's type geometry. And let's find this black hexagon. It's a container again. We are going to store this information. So right click on the geometry, set one geometry, and let's select this cube. So just associate, let's reference this cube here. And remember that the thing we did in the last exercise that we use volume to find the center of this, yes? Yeah. Sorry? Let me see. Yeah, you do have cube. Oh,
Now when I go to wireframe,
what's going on here? I think you are in a different rendering mode. These computers. It looks like it's locked. Okay, you do. It's just like you can select it, but it's just like it doesn't highlight. So some people change the setting here. So it's okay. You still can move it, and if you go to your, let me see if you can select it. Yeah, you are fine. All right. Okay, so let's use the volume. This M cube, this uh, with this icon, this M cube, this thing. So we just put a geometry here, and you will give us the centroid of this geometry, right? So you can see if you click here, let me hide this thing. You will see a point that's the centroid of this cube, right? So the other thing is straightforward, that as long as we can find the vector from this one to all the points here, and we just move it, right? Just move it. So let's create a vector. So just double click vector 2-point. So this, please find this arrow with 2 points. It's called vector 2pt, right? So vector has direction. So that will be point A to point B. So start from the centroid, it's going to point A. And the point B is all these kind of points that we've just created, right? Here. So there's a point matrix. It's like a transformed point matrix. So I'm going to put a scribble. So there's a point surface. Let me be more precise. Surface. All right. So this is a surface. Let's use another scribble. Surface. Recreate. Right. And so all these points will go to the point B. Right. The same thing if you want to visualize it, you can use line. This line with this, I'm sorry, the line, this with two white point, this one, you can visualize it. Oh, sorry, it's center. So that's a vector that you are going to, of this component generated. It's just visualizing the vector. So you just create a line. It's the same thing. So now we're not going to use a line. I just want to visualize it for you, right? So the next thing is move. Double click. Let's go to move. All right. So the geometry we want to move is this cube, right? This cube. So let's put this cube into the geometry. And the motion is the vector, right? The motion is a vector that you want it. How do you want it to be moved, right? So go here. All right. So look at this. You can go to bake it. And let's take a look at this thing. So that is a very simple way to materialize it, right? To put a material here. So that's the first thing. That here, the first thing we have the surface, and the next thing, where is it? Right? The first thing is this surface. We already have it. The second thing is these cubes. You can adjust the size of the cubes. In this example, I use a smaller cube, so there will be gap. And here I'm using right now these cubes. I just calculated, so just like a 1 unit by 1 unit, so it will be side by side, so there won't be a gap. All right. Okay. Let's go back. So here I'm going to put a scribble again. I would say this is a material mapping point surface, right? So this is the point surface that means we create a surface. We create a lot of point, we move it, and this point looks like on the surface, right? And I just put the material on top of it. So I just put it here, and here I'm going to use a scribble as well. It says this is a motif, cube motif. right? So of course you can, here's a challenge to you, that see if you can use the same distance that calculate from the point to change the size of the cubes here. So if you are far away, I'll become smaller. If you are closer to the extractor point, the cube will be bigger, right? Try to implement this thing. There's a challenge for you. So now we're just moving, right? And then think about how after we move it, how to change the size of the cube. All right. So that is a challenge to you, right? Let me move the entire thing down a little bit. Have more space. Okay. I think this part is straightforward. Let's keep going. All right. Now I'm going to do this thing. Since we have the surface already, right? I want to have the entire volume. They are all points. So underneath is a lot of points as well. So it's more discrete. If we go back to the sample, you'll be like this one. All right. I want to do this one. Okay. So how do we go about it? And also, here's one thing is that you can see these cubes, they are moving that not in a discrete way. So it's like a continuous way. So you can see it's not always moving in one unit. So I want to make it more discrete. So like a Minecraft, right? So let's do a Minecraft topography. So the idea is I want to go back. So let me disable this component we already done. So this is done. Let's turn off it. All right. Let's go back to I'm going to disable this surface as well. So we are not using it right now. So what I think is we have the points on surface like this, right? And I want to see the bottom one, right? The one before we move. So let's go back to the point matrix. We can be more precise on XY plane. So I'm going to turn on the preview. All right. So I have the point matrix that before moving, and I have the point matrix that after moving, right? So that is. So what if I just connect this line? So 1.1 go to 0.1, 0.2 go to 0.2, 0.3 go to 0.3, and I use this distance, and I cut it into units, like 1 unit, 2 units, 3 units, right? So I make the units here and create a point. So like in this case, I'm going to create a line, and I'm not going to directly divide it. Instead, I want to find 1 unit, 2 units, 3 units, 4 units, all the way until it surpasses this value, right? So that's what I want to do. So first thing, I want to calculate the distance here. I'm going to use a point, a black hexagon, to store this point from the point matrix on the XY plane, this one. All right. Okay, this one. Because I'm going to use this one here. Let's put it in here. Let me change this place. You don't have to do this. I just want to organize my code a little bit, because this is the first thing we generate, and the second thing we generate, and the third thing that we are going to generate is these cubes here. That sorry, the units here, right? So this is a point matrix. I'm sorry, I just put a scribble again. PT matrix on XY. I just give the note to myself. Right? I didn't do anything. I just store it again, just line up, because I don't want to be I don't want it to be a very long wire that connect to somewhere here. So I just use it like a stop here, right? So let's do a distance calculation. So double click distance. So find a ruler with 2 points, right? So before we put it into this calculator, let's check out how many points we have here. Just make sure that do we have the same number of the points, right? So you can scroll down. There's a 675 plus 1 point, and this one is the same thing, 75, 675 plus 1, right? So that is correct. So we just put them together, just one by one. So the list go to the point A, the geometry, this one, and this go to point B, all right? And there should be 675 plus 1 distance, right? Okay. If you look at the distance it calculated, it's fractional number, right? It has points. So what I want is discrete. So I'm going to discard the points, the digit after the point. So here, let's use double click. Let's type integer. Integer. Here, the black hexagon. There are two black hexagon. One is called get integer. The other one is just integer. It's a container still, but it has a function that when you put the number in, you will discard. You run the number, just give you the integers, right? So there won't be the digit after point, right? And now, so you can see this is 10 units, this is the 9 units, this is 8 units. So it is straightforward that we just divided it into, so the box is 1 unit, right? So we can just divide 1 unit. If you change the box dimension to 0.5 units, and you will divide more, right? So here, just in case, I'm going to use a division. So please find a division here. We can use integer division, but let's use division directly because the input might be fractional. So just do the division here. So A divided by B, right? This one, all right? And use a slider. Just I use 0.1 5. I'm going to set a value as 1. So that's a unit, the dimension of the cube I set up, right? So I draw the 1 by 1 by 1 cube. So this is a cube script. Let's put a scribble here. That's a dimension of cube, right? So just give us a sense about this thing. So the integer that we calculate the distance from this point, the bottom point to the up point, is here. We turn it into integer, and here we turn it into integer again. That we divide it. So actually, this is very redundant. You can see I divide by 1, so it's itself. However, if you change the size of the cube, like I want to use a smaller cube, and you need to come here to change the dimension of the cube, so 2.5. So that's why I set up here. It looks redundant now, but it's actually very good in the future application. So if we use the panel, see this again, okay, which is fine. But still, just in case, I'm going to use an integer again to transform everything from the outs. For example, if this is 2, right, it will become not integer. So I will still use this thing as an integer to turn it into integer, right? So that means when I calculate this distance and I put it into integer and divide it by the cube, the dimension of the cube, the number output here means how many cubes you can put it in, right? How many cubes you can put it in. So that is a way we can do that. All right. So now we can say there are 10 cubes we can put it in. For example, here there are 10 cubes we can put it in. So I want to develop not sorry, copy this point 10 times. If I have 10 cubes, I just follow this thing, just copy this point 10 times. And if you can only have 5, I copy this point 5 times. And then after that, I just move the cubes together all to this point. So first of all, I want to create a point first, and then I would do the same thing, just like I move the cubes, right? So I just move them here. So I'm going to create the point. So here, just follow me. Let's use range, right? So here's a tricky thing. This is the entire distance, and this is how many cubes you can put it in. So what I need is to create a kind of a steps. Like if you have a 10 and I have 10 cubes, right? So every step is 1. But if you have 5 cubes, then every step is 2, right? So that is why we need to use this range component to calculate the actual moving unit, the how long that you want to move. This is the number of the cubes, and there's the entire distance. So that means if we go back, that will be how every cube you want to move how much, right? So just follow me. It's okay. So this distance after this integer, let's put it into domain. And this integer is how many cubes, let's put a steps. So it is still the same like this one. However, we say the first point, move 1, move 2, move 3, move 4, all the way move 10, like this. So that's why we need to create this kind of list, right? Okay. Just follow me. We can talk about this thing later if you are confused. All right. So now I'm going to put these numbers into Z vector to create a kind of motion, the vector that I'm going to move this point. So this one I move once, twice, third time, 4, 5, 6, 7, 10, all the way to here. Some points like is lower here, I just move it 5 times, right? So that's why we use the range to create a kind of a series of number, all right? So let's use unit Z here. So this is how many points we need to create. How many, sorry, not the point, how many vectors we need to create. So we have that many vectors. The next thing is we need to move the points from this point matrix on the XY, just move it multiple times according to the distance you calculate, right? So that's move, just move. And this moving go to the motion, this Z go to motion. Before we put the geometry here, let's double check it again that this is grafted structure, right? And how many, so there's a list within the list, right? So that's graphed. So there's a lot of room. Every room has different numbers, like 10, like 9. And how many rooms here? We have 675 plus 1 list here. Why? Because every point needs to be moved multiple times. So every point on the bottom here, on the floor, if you are closer to the point, if the point above you is closer, I move less, right? But anyway, I need to move that many times. If you are far away, I need to move more, right? So that's why every point has multiple moving vectors. So this is only for one point. So for this one is 1, 2, 3, 4, 5, all the way to 10. The second one is 1, 2, 3, 4, all the way to 9, right? So that's why we have this kind of graph structure. However, the points we want to move is actually from this one, right? Point matrix on XY. They are in the same lobby, right? All in together. So before we put it in, we need to graph it. So that means, okay, this point you go to the room 1, this point you go to room 2. So that's graphed here. Go to your geometry, the moving move component, hover over on the geometry input, right click, let's put graphed. So that will make sure that the points are input is grafted. So one point is one list. So list one will pair the list one. List two will pair list two. List three will pair list three. Otherwise, if we don't graft, that'll be the entire 600 something points work with list one, list two, list three. So that'll be 600 multiplied 600 something. That many operations that will crash your system very quickly. All right. So let's make sure that we have graph here first. And the other thing we need to do is to grab this point, right? The point matrix on the XY plane and put it here. All right. For now, I want to disable the view of this point on the surface. I just leave this discrete view. So this is Minecraft. Right? So we have this point. And the next thing is pretty straightforward, right? So once we move it, we use move again to move this cube. Where's the cube? Here. The cube again to all the points, right? We have this point, right? And here I'm going to flatten the output, the point, because now I don't need a graph structure. So I can just put them all in the same list, right? Just reduce some operation, loading. And use move again. And before we move, we need to calculate the vector again, right? So let's use vector 2 point. So from the cube to the point. So again, so we already have the centroid. We calculate here. Let's go to the centroid is go to A. So the cube centroid, right? And this is all geometry, those points. We calculate, we go to B. Right? You also can use line to visualize it. So those vectors we created. So from this point to this point to that point. Let's visualize it again in case that you're confusing. You don't have to do this thing. I just want to visualize it to you. So those are the lines, the vectors I want to. Okay, give me 1 second. I'll be there. Let me finish this thing. Okay, so these vectors, that's from this point to this point, this point to this point, all the points that we just created, and those are the vectors. And so those vectors is go to the motion, and the cube go to the geometry. All right. So you have Minecraft now. You can change the point here and there. So the entire thing will change as well. You can play with it. Yeah, sure. Let me enlarge the entire window. Right? Okay, it's okay. I'll be back.
Okay, my only question was what did you do? Like where was everything that you plugged into like here?
Oh, so vector is like we want to create from this point to that point. We want to that point, right? So this point, right, go to B, and this line geometry, the cube center, right, the centroid, go to the point A. Yeah. So we create that many. Yeah, there you go.
Um,
All right.
so on the first one you did, like where it was just the cubes,
Uh-huh.
this was right up here.
Okay. The centroid vector. This is wrong. Where's your cube? Let me double check. Should have sent. Isn't there's no data, so that means your cube is wrong. Where's the delete? Okay, okay. So the cube might be wrong. Let me do the cube again. Box, box.
So I should have said something earlier, but I'm gonna stop it.
It's okay. No, you have to. It's okay. We learn together, so it's fine. Let me associate this thing again. What is fuck? Set one geometry. Object reference. Gosh, it's weird. No data. No data. I think you're offline. Your grade separator is not linked to here. Save the file. Open it again. Why you have this red color frame?
Does it matter if you open up?
Sometimes. Let's save the file and reboot everything. All right. Okay, reboot everything. Open the Rhino first. So it might link to other grade separator file. Yeah. Okay, save the file and open everything again. Yeah.
I don't know what I did, but I always have a hole in my construction and also between the.
Oh, you are not discrete?
No, I have no idea.
It's okay. Let's check out. So this is distance, this cube. Let's check it out here. What's the size of the cube?
One by one by one.
One by one by one. Division, range, unit. It should be fine. It seems that you just have the bigger cube.
Okay.
Yeah, so go check out your cube's dimension here. So make sure that you have. What is
No,
it?
this is just a point of the.
Oh,
The cube
this.
is, I think the cube is.
Oh, here. Okay.
But I
Let's see. It's okay. Oh, okay. It should be fine. Let me see. Oh, because you have different setting here.
okay.
Yeah, it's okay. You are fine. Yeah, you just like adjust this thing, this 25 by 25 unit. It should be the same. XY is the same, so XY is good, but Z direction is wrong. Okay, that's not this thing. Let's go here to check. So we have the distance, surface distance calculated with the integer here, the integer again, steps here. So that should be fine. Okay, so you can see this is not integer. It should be integer. So here is something wrong. That would check. Let's check it out here. So go here. So that is wrong here. So that means these not matching here. That means these division. Why you have weird. Oh, sorry. It should go here.
Oh.
Yeah. So yeah. Command. Where's Z?
Command Z, yeah.
Yeah. So not from the distance.
Okay, thank you.
Yeah. Where? Uh, it's it's freezing.
Mhm.
Save the file, reboot it. Save the file and reboot it.
Sure.
All right.
It's all good except for one thing.
Yeah.
I don't know why it's just red. I think it's some point.
Point from matrix.
It's also just.
Yeah, it's not. It's not this. This should be from 25 here. This is a U count. Yeah, it's okay. So that this component when it's generating this kind of calculating the surface, it's where is it? Here. It requires the count, the how many units you have here. So that's why. Okay.
All right. Thank you.
No problem. Everyone is good. You all have these cubes. Okay. Let's keep going. Honestly, let me know if you're okay. Just reboot everything, right? So here, let's put a scribble. This is a Q point in volume. Material mapping. You can have your own name. You don't have to follow my name. My naming. It's just like I use this thing to just make a note. So just let yourself know that this is the output that we want in the end, right? Okay, so done. Another one. How many to go? Okay, we're here, right? So this volume. We use matrix to represent it. Use points to represent it. Right, this one. No, sorry, not this one. This one, right? So you can go back to adjust your point, the cube size, and also the dimension of the cube, so you can have multiple different density. You can go back to play with this attractive point. You can see if you are down, right? You have different topography, right? Hey, I'm going to disable this thing first when we are moving on because it is really heavy. I'm going to disable it. I'm going to disable all the points here. Not disable, just hide it. Just disable the preview of it. Right? These we don't need it. We just disable the preview. So yeah, fine. And I'm going to go back to turn on the preview of the point matrix on the surface because we want to move it to another one. All right. So we use the point to represent the surface again to represent the entire volume, right? So now what I want to do is to create the lines. So that's another straightforward one. Just play with it. How about just connect these lines and we just extrude it with something, right? So for example, that this one, that from line point 1 to point 1, point 2, point 2, just create these lines and we extrude it. Like use a tube or use a pillar or column, anything, profile, right? So I'm going to create this line first. Right? Just to visualize it. So this is a point matrix on the XY plane, and this is a point matrix on the surface. So very straightforward. Let's use line, this component, that black line with two white points. So I just connect these 2 points, right? Let's see how it looks like. So I would like to use this representation to describe the entire volume. Right? Okay. And my idea is that what if we can extrude something that we draw? For example, if I draw the circle, like a profile, I just like a toothpaste. I just extrude it in a different height. So for example, that height, that height, that height. So the the design actually I want to do is this one. So it's like a lot of columns like this, right? However, I want to give myself a little bit flexibility because this is a cube. This is like a square profile. What if I want to use a circle? What if I want to use something else? It might be beautiful, right? So I'm going to draw a motif like a 2D drawing, like a profile, and I will load this thing and move it to this point and extrude it, right? So that we can have more design space. So let's go to the Rhino. I'm going to just use a circle. You can use more complicated things, like if you want. I just want to make a circle. And I want the radius is 0.5, right? So this. So when you make a circle, you go to Rhino and use circle command and just type 0.5 directly. Oh, you click the position, the location you want to create a circle, and type 0.5, and that would give you the radius, right? Okay, so this is a extrusion motif that we want. So again, I'm going to use a curve in the grasshopper. Just follow me. Double click, curve, find this black hexagon. All right. And I'm going to load this curve. So double click, set one curve, select this profile. I'm going to give it a scribble. So that's a extrusion motif profile. Okay, extrusion profile. Here. Right? So we just did draw a circle in Rhino and use this black hexagon, the curve, black hexagon 1 to associate it. Exactly the same thing that we move the cube. But this time we want to move these circles to all the points here. On the bottom only. All right, on the bottom. So remember how we find the center of the circle, the area, right? We use area, double click area. And you give us the center of this circle. And then we need to calculate the vector again. 1, 2, 3, all of them. So let's use a vector. 2 point. So from the centroid of the circle to the points on the XY plane, right? XY plane here. To the B. Exactly the same thing that we just move this object, copy this circle to the base here, right? So the vector go to the motion, and the circle, this one, the extrusion profile, go to geometry. You have that thing like this, right? That's the reason why I use 0.5 as the radius, because I want it to be side by side, right? Right? And then the next thing is a new component we are going to use is called extrude alone. Extrude alone. So you can see this kind of skewed extrusion icon. This one, extrude alone. Right? Extrude alone is a component that you might use it, but sometimes it's very difficult to use it because it's like give me the curve and give me the profile of the base, and I extrude it just like extrude the toothpaste, right? However, it doesn't really change the base direction. So if your curve it looks like this, you extrude in this way. It's not that smart to give you the profile that you turn the extrusion profile. You just remove the extrusion profile So sometimes when you are using this component, you have to be careful. But this case today, we are going to do is just straight line. So it's fine. We are not changing it's not a curve, right? We just use straight line. So it's good to use this thing here. So these are the circles and the lines are here. Before we put it in, still, let's double check how many circles we have. So we have 675 plus 1, right? Circles. And how many lines we have? So we have 675 lines. So that's good. One circle, one line, and that's it, right? So the base is the profile that you want to extrude, the profile. And the line is a curve, so along the curve. So extrude along means the curve, right? Is upside down. Because when we create a line, we start from the surface to the XY. So extrusion will follow the direction that you create. So in Rhino, every line has a direction. It has start and the end. So it has direction, right? So in this case, we just need to flip it, right? The easy way is to just swap these two, right? Just swap these two. So let's swap it. So this one go to star, and this one go to end, and that's it. Right? So you can bake it to see. I got this design. The idea of this design is from the noise architect, the installation he did in the hotel. I didn't really cap it. You can cap it. So if you want to close this tube, you can use the cap. So let's go back to the Rhino. Oh, sorry, the grasshopper. Remember we used this before. Double click cap hose. You can cap the cylinders. It becomes a cylinder. You bake it. And you have cylinder like this. But from my personal perspective, I like it. It's not capped. So up to you. If you want to cap it, you can cap it. I would like to leave it open. And here, if you want to change the motif, then okay, this is a cube, this is a circle, right? You can go to associate other thing. I'm going to create a one by one square in Rhino. So I just use rectangle. I go to Rhino. I use rectangle to command. Rectangle. Click the first point and type 1 and 1. And now fix the length and width to 1 and 1 unit. I'm going to just change the motif, the extrusion profile to the square one, and you have a square one. Again, you can cap it, so you will have exactly the same representation that we had in the example, this one. Or you don't have to cap it, you have tubes again, like this. In this specific design, I like circle one more. So I'm going to change back to the circle one. Where's my motif? Here. Looks more elegant. All right. Bless you. Okay. So this is I'm going to put a scribble here. There's a line representation, material, mapping, line, volume. So I use the line to represent the volume. Again, you can have any kind of name you want. Mhm. Be careful if you want to increase the density of this entire thing. You might need to go back to change the size of the circle if you want this design still like a side by side, because you can see the motif won't change the size, right? The profile won't change the size, but if you increase the density here, so for example, we are having 25 by 25. If you want the higher density, 50 by 50, then you might need to go back to change the circle size, right? If you still want a side by side, this kind of a good quality of the work. So here's another challenging that if you change the density of the grid, can you set up a code that you don't have to go back to Rhino to change the actual size of your motif? Think about this thing, how to do it. All right? Unless you are good. Okay. Everyone good? Let me enlarge this thing.
Anytime I make something with this.
Change one.
Huh?
Change another one. But I saw your design here.
Yeah, but it just crashes because I baked it. Now I can't like delete the bake.
Okay. In this case, I would suggest open it again. Just
Alright.
reboot it again. Open it. Change the density up front. Okay. Oh, you just change the laptop. Okay, desktop. It shouldn't be that heavy. This one should be lighter. Yeah. Let me see. Let me see. Other people good? Let me see your grades out there.
Like I can't take this big.
Oh,
I'll remove the viewport.
it could be very.
Just the PCS.
Mm, no, probably this kind of representation is bad. So it might running some rendering behind that default setting. Some people change this kind of thing, so that's why it has this representation. Yeah, so I would suggest just select another desktop.
Okay.
Yeah, but files you can find all the files, right?
What do you mean?
Even though you change the
Oh yeah.
because they follow your profile.
Yeah.
Okay, cool. All right, everybody's good. I think this one is just straightforward too. Okay, let's keep moving. We have so many things. See if we can finish this today. All right, so we have the lines. How many we have? We have 4. We have in total we have 16. So let's see. All right, so we're where we are. We are here. We done this one. All right. Very nice. Very nice. Almost there. All right. So next thing, I want to go back to see if we use the lines. The lines that we are using is z direction. How about x and y? Right. So the surface can be represented. So of course, z direction cannot just use the line to represent the surface because it is in the different dimension of this different direction of the surface, right? So, but I still want to milk this idea that let's use lines in the x and y, so like it would look like this one. All right. So let's try to get this thing. All right. Let's do it. Okay. So we have the point matrix on the xy. I'm going to disable these tubes as well, that we are not using it right now, and all the other things I just hide them. All right. XY, I'm going to hide them. I just keep these points on the surface, this one. All right. Okay. So question, we have so many points here. What if I want to connect these lines? Just like an X and Y separately. So idea is that everything is in the same lobby, right? Again, all the points are in the same pool. But I want to grab the first column or first row of these points and put them into one room. And I'll use a component to just connect them, right? So if we go to our point matrix, on the surface, let's check it out here. They are all together. There are so many points, and they are all together, right? But we know that there will be 26 points here, right? And 26 points here, and they are in order already. So what if we just separate this list? 0 to 25, 26 to 50, 51 to 75, something like that. So if we can separate this list, that will be one by one, right? First one, second one, the third one, the fourth one, all the way, right? So that's what we are going to do, right? So just follow me. This will be a little bit abstract, but it's a very good exercise for the idea of a data structure. So let's do this thing. Just follow me. I'm going to do a series. Double click a series. Remember the series? Series component would create a series of numbers. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, like this one, right? So I start from 0. If you don't do anything, the default setting is 0. So, but just in case. Just follow me, I'll explain this thing. Use a slider. Let's type 51. Let me double check, sorry. Not 51, 26, because we are using the 25 here. So I want to create 20, so this one. You can grab this thing and plus 1, but for the convenience, let's do the 26 for now. We can change things later. So let's put it into the step. So you can see, I want to use these things 0 to 26, 26 to 20, 52, 52 to 20, 78, blah, blah, blah. So that will be the index that I want to separate the list, right? And how many of them? 26 of them, right? So this goes 26. So it's 26 by 26. But just in case, let me put another 26 here in case we want to change. So that'll be 26 things of 26. All right, 26 of 26 things. Right, 26 points, 26 points, and in total we'll have 26 groups of 26 points. All right. So that is the first index that we want. The first index. So start from 0 and I want to go to 25. And 26 go 25 go to something like that, right? So I'm going to use another series. Just follow me. I start from 25 and we have the same step and the same count from the above. Let's use a panel to see the output. So this is the index I want to grab this point. 0 to 25, 26 to 51, 52 to 77, 78 to 103. So that's a group I want to generate. So that's why I use two series component to generate this kind of two series of index. So let's not struggle here. Let's just move on, right? And now I want to create a domain like this. Domain 0 to domain 25. One domain is 0 to 25. Another domain is 26 to 51. So that's double click, construct domain. So let's find these. Where? Construct domain. This 0 and 1, this one. All right. So this is the domain start, and this is a domain end. Do we have that many things? So this is the first one, the second one, the third one, right? So we have 26 domains. Every domain has a range, another domain, right? So like a 0 to 25, 26 to 51. Now let's use another component. It's called sub list. Sub list means that give me the domain. I'll give you a subset of your list. For example, you have a 0 to 10, like a list have 0 to 10 items. They said, okay, I give you domain 1 to 3, and you give you the sub list, like 1 to 3, item 1 to 3 to you. So it's like a little bit like a list item, but you can give it a domain to push a lot of things out, right? So the list is the point on the surface, this one, right? So I'm going to use another point hexagon, black hexagon one to store it. Put it here. Use a scribble. There's a point matrix on surface. So this is a list, and we want to have the domain here, that many domain. And now you can see those points are divided into 0 to 25. That's the first column. We can use the list item to check out. You don't have to do list item. I just want to visualize it for you. So you see, this column is out. So divide it. So now we separate them. Can you see that when I highlight it, they are separated, right? Honest, I'll help you. So let's finish this first, right? So the next thing is straightforward. Since we have these groups of points, we just put the one group into a component to create a curve. Okay, so there's another component. Let's do this thing. It's called NURBS curve. It looks like a Bezier curve or something, that NURBS curve. Let's use this one. There's another one called NURBS curve PWK. Let's not use that one. Let's use NURBS curve. This one is like a reverse C, right? So vertices is that this component is you give me a bunch of curve points in the order. I just create the NURB curve for you, right? So that's straightforward. Let's put this list into the vertices. You would immediately see these curves already. And just in case I want to give it, default is a degree 3. So curves have degree. So if you have degree 0 or degree 1, that means straight line. Degree 2, more smooth. Degree 3, even more smooth. So I want a smooth one. So I'm going to put 3 in the panel just to make sure that this one I can control it. You can change it to 1 to see the difference. If you go to 1, you can see it's like a discrete. It's like a line now. It's very discrete, like this. If you turn it into 3, it becomes smooth, right? Okay, let's stop here. You can bake it to see it. Once we've done this one, it'll be much faster. So that's a curve we generate. Okay. Right.
I think I messed up something with the list item because when you like scroll through, it does like.
Oh, okay. Yeah. The index might be wrong. So where's index? Oh no, don't do this item, just this one.
Oh,
But still, this one is wrong. So, um,
And I tried to be a little too fancy. I tried to connect this back to
Okay,
your base number.
I see. It's okay. That's so. What is it? This is 25
Yeah, and then I just
and
did plus one. And
plus
then,
one. Okay, that's good. And 26. And this should be 25. Yeah. Star. Oh, then you need to have an expression here as well.
oh, I do.
Plus one. Um, x plus one. Now you have the curves.
Oh my gosh, that's
Yeah.
just fun.
Look, don't worry.
So frustrating.
You okay?
Thank you.
Random went open, but I was following along with last part.
Okay. Just
So I'm gonna try to swap these.
yeah. Stay. Yeah. Let me help you after the class. All right. Anyone? You're good. You can see the lines. You all have the lines. Okay. So the next thing is just give it the material. Let's pipe it. Let's pipe it. All right. Just like the exercise one, we use pipe to give this thing, a material. So I'm going to pipe it. Oh, we can pipe it now. Pipe. And I'm going to give it a radius like 0.1. I don't want it to be too big. And I use Boolean toggle. You're already familiar with this component, right? So the pipe, and I set up the 0.1 as the radius, and I use a Boolean toggle. You just type Boolean toggle, and it's true because I want to cap it. And so these curves, before I put it in, I just flatten it. So here will be a pipe like this. Let me bake it. So you have the x direction. It's actually, x direction. So I'm going to put a scribble here. Material, mapping, x, line x, surface. So that means I use the line in the x direction and to represent the surface. Right. Let's do one more thing. So we have the x. How do we get the y? We have this sublist. But the sublist is like in this direction, right? 1, 2, 3, 4, 5. We want to flip it, right? So like in a list, like a 0, 1, 2, 3, 4, 5, 10, 11, 12, right? So another list, right? Now we want to grab every first item from every list and put it in together. Second item from every list, put them together. The third item, put the third item from every list and put them together for a new list. So this is actually a matrix. Are you familiar with the matrix? Matrix 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like this is matrix. This is an array. In this data structure, we have this matrix like a 0 or to the 25, 26 to something, something to something, right? We have this kind of structure. So this will be one curve, this one curve. What we need to do is actually flip the matrix. So all the first item in the list will be collected together, become another list. And we use this thing to create a curve. Right? Do you understand? So it's like we have matrix like this, or we just want to rotate it. It's like rotating 90 degrees. So it's called flip. So here we are going to use a component called flip matrix. Flip matrix is a lifesaver that in the end, that if you want to, we get into the project, you will use this a lot. Just rotate the matrix. So the thing is straightforward. That's just put this list into the data. So you can see This is actually flip already, but because we have the 26 by 26 matrix, so it will be the same dimension. Like still, the first one will be 26, the second one will be 26, right? So just in case, let's check 26 items. That's good. And all the other things are just the same. So I'm going to copy paste all the components above here. And these go to the vertices. And you have Y. All right. So I'm going to change the scribble here. Just go to Y. I didn't do anything. I just copy paste all things and just flip the sublist things here. I'll have both of them. Let me stop here. Let's call. We cannot finish this exercise today, but we are almost there. There's only a couple things to go through, so we will finish the assignment next Tuesday. Okay, so before next Tuesday, I would suggest you just think about how to use the distance again, because it's a attractor point. We just use it to move it. How to use the shrink or enlarge the components, just like a cube, right? Can we use these parameters to control the size of a cube? We all know how to use scale components before, right? In the first exercise. So try to think, introduce more different transformation on this thing, all right? So the same thing that all the parameters can be controlled by the distance again. For example, the pipe radius. Can we have this pipe radius as a variable, and it will change according to where are you far away to the point, or so you have different density, different size of the tubes, different size of the cubes, different size of things like that. Even the circle on the floor, the thing we extrude, right? This one. Think about it, how to use the distance to control the size of this. If you are far away, if you are smaller. If you are close, the circle will be smaller. If you are far away, the circle will be bigger. And extruded will have different density. Right? So it's just try to recall what we did before here. Long ago here, we remap things, right? But this one, think about this thing. We just use this thing to control the moving up and down, right? But it can be a lot. So try to implement this thing. Any question? If you have the question about a code that you cannot follow, just stay. I'll stay here for 15 more minutes. Otherwise, you are free to go. And also, I uploaded the recording last time. But still, I was think that don't try to catch up just watching the video. If you have question issues, just let me know. I can address things here directly. All right. Sometimes we cannot cover all the questions in the video. All right. So you might have very different questions. So just let me know. All right. Is Ryan here? Okay. So I need to talk to you about the natus. Do we have natus? Probably no. Right, Luisa, Anas. Okay. Save the file.